Question 19.54 says, predict the major product or products from the treatment of acetone, which is this ketone, simplest possible ketone, with each of the following. So we'll start with A. So we're treating acetone with a catalytic amount of acid, ammonia, and we're losing water. And so what we're going to end up with is, instead of a double bond to oxygen, we'll have a double bond to nitrogen, like this, and this is called an imine. In B, we're doing something similar, so I'll just copy, except now we're using a primary amine. This is called methylamine. And so we're still going to get an imine, but instead of having a hydrogen attached to our nitrogen, we'll have that methyl group. So again, we're producing an imine. In C, we're treating the ketone with excess ethanol, which is an alcohol, and we're losing water. So we're going to produce an acetal. So our carbonyl carbon will now have an ether bond to an ethyl group and another ether bond to an ethyl group, like that. And so we end up with an acetal. In D, we're treating it with a secondary amine. This is called dimethylamine. And so we're not going to get an imine this time. We're going to have a bond to our nitrogen like that. We're going to have the two methyl groups, but now we're going to have a double bond here, and this is called an enamine. So remember, when we treat the ketone with a ammonia or a primary amine, we get an imine, and when we treat it with a secondary amine, we produce an enamine. In E, we're treating it with hydrazine. That's the name of this compound here. It's called hydrazine, and we produce a hydrazone. So now we have a double bond to our nitrogen from the hydrazine, and we have our NH2 over here. Next, we're treating it with a catalytic amount of acid and hydroxylamine, and we produce an oxime, or an oxime. So this is an oxime. There we go. So that's a new functional group. In G, we're treating it with sodium borohydride in methanol. And for that, we're just going to straight up reduce it from the ketone to the secondary alcohol. So we produce isopropanol. In G, we're treating it with a peroxy acid. So we're going to do a Baeyer-Villiger reaction. So this is a name reaction. It's the Baeyer-Villiger reaction. And we end up with an ester. Next, if we were to treat the ketone acetone with HCN and KCN, we make a cyanohydrin. So on what was the carbonyl carbon, we now have a hydroxyl group on it, and we also have a nitrile like that. That's a cyanohydrin. The next one is a Grignard reaction. We're treating the ketone with ethyl magnesium bromide followed by water. So you can imagine the ethyl is a nucleophile, and so that's going to attack here, and we're going to end up with a tertiary alcohol, which would look like this. And so this, again, is a Grignard reaction. The next one is a Wittig reaction. We just have an ethyl group over here, so this is not a stabilized Wittig reagent. And so we're going to end up with the Z alkene, but there's no E and Z in this case since we have two methyl groups over here. So we have those three carbons from acetone, and where the double bond is, right here, now we're going to attach all of this. So we have our double bond, then we have CH, CH2, CH3. And again, E or Z doesn't matter here since we have two methyl groups here. And the last one, I'm treating it with lithium aluminum hydride followed by water. So again, that's just a straight up reduction to an alcohol, and so I end up with isopropanol in this case.